Welcome to this lesson on data and measuring. So this video is going to be a little bit interactive. There's going to be sections where I'm going to ask you to pause the video and discuss with your group. So at that point, just pause it, have a bit of a chat with each other, brainstorm, come up with an answer to the question, and then unpause it and I'll either go through it or I'll just keep going on to the next slides. So the first little activity is I want you to look at this image that you can see here, and I want you to describe from the image all of the observations that you can come up with. So you can chat with each other or make a bit of a note on a piece of paper or your computer, but just what are all of the observations you can see? What kind of things can you come up with? So this links to the qualitative and quantitative aspect, and I'm sure you've already seen this from last year, but in a nutshell, we've got these two main types of data or observations that can be made. We can have the qualitative, which is more linked to your senses, so what do you see, hear, smell, taste, etc. And these are qualitative because they include things like a shape, a color, a hardness, a roughness, sweetness, etc. So one example is from that image, Eli, who was the guy on the left, has a white shirt on. Or Angelica, the female, is the shortest in the group. Or something like the group looks scared. So this is qualitative data. Quantitative, on the other hand, involves counting or measuring. So it's a quantity of something, which is where the word comes from. So this could be answers things like how many or how much. It always involves numbers as well as the words. So an example from that image would be that there are 3 people in the photo, or Josh has 3 crowns on his skateboard. These are examples of quantitative data from the image. So from the activity that you did before when you talked about what you observed in that image, I want you to categorize all of those observations into qualitative and quantitative. So just put like a QUAL for qualitative or a QNT for quantitative next to all the things that you wrote down. Quantitative data. So to make quantitative observations, we need measuring tools. We need, if we count a person, that's easy enough. We can just say there's 3 people in that image. But if we want to measure things scientifically, we need a tool. So we need rulers, we need thermometers, we need scales, all these kinds of things. So we need apparatus, as we would call it in an experiment, in order to obtain this. If we're comparing the two, I want you to compare these statements and say whether they are quantitative or qualitative. So in these examples, I've got Rick's body temperature is 24.5 degrees Celsius. Rick is 70 years old. Rick is 178 centimeters tall. He has blue hair. He has an awesome lab coat. Rick is skinny. Rick weighs 68 kilograms. And Rick has a cool portal gun. So pause the video, chat with your table about which one these would classify into. And in just a second, I will give you the answers. Okay, so Rick's body temperature is 24.5 degrees. That is something we would measure with a thermometer, so that is a quantitative value. 70 years old, that's a little bit of a tough one. We definitely measure that. That's not using your senses, so that would be quantitative as well. 178 centimeters tall, quantitative again. We use a tape measure to measure that. He has blue hair. That's not really something we can measure. That's an observation using your eyes. So we would say that's qualitative. What defines blue? There's no exact answer to that necessarily. Here's an awesome lab coat. This is an opinion statement, so it's absolutely qualitative. Skinny, again qualitative. You can't measure skinny. However, 68 kilograms, that's a mass, and that's taken with scales. So that would be quantitative. And cool portal gun is again an opinion. There's no way to measure what is cool and what is not, so that is also qualitative. Now, a very important aspect is measuring accurately. So the accuracy of a measurement is how close to the real value or how good a result is. Whereas an inaccurate measurement is not really useful. It's going to give us some dodgy data, and that is not good in science. So if a thermometer tells you that it's 35 degrees Celsius on a cold day, you're obviously going to need a new thermometer. There's something wrong with it, and we can't use that apparatus in the experiment because it's going to give us real dodgy results. So scientists need to make their measurements as accurately as possible, and this means taking a lot of care and making sure that the instruments are used correctly. A A source of error. So when we talk about sources of error, this is things that cause an error in our result. And an error is just a value that is either completely wrong or a value or multiple values that are all shifted by a certain amount. So sources of error are things that affect how close you are to the result, or what you would get, or what you would expect. So sometimes I would give you an experiment, or you'll do an experiment where you know the answer and you're trying to confirm it. So that way you know if you don't get the right answer, there's something gone wrong in the experiment. In this image here, the student at the right is at the same height as the liquid and is going to get a much better result when they're reading that measuring cylinder than the student on the left. We call this a parallax error. So this is because this person can see at the level and they don't have this angle, whereas this person will look down on it, and these numbers up here are actually going to look like they're very close to what the reading is, and the result will be quite off. So whenever you want to read from a cylinder, you should get to eye level and read horizontally across to that point. Apart from being a vital piece of cartilage in your knee, the meniscus is also a curved surface of liquid where it clings to the sides of the container. So it creates this phenomenon because the water is actually sort of attracted or sticks to the container, and so it creates this little curve shape. Rather than being perfectly flat, water actually creates this curve. So this presents a problem because when I want to measure this, do I measure the lowest point? Do I measure the highest point, or somewhere in between? And this is obviously going to shift our values. You can see here we're talking probably half a milliliter in between, and that could be quite significant. So would you say this is 36 mils or 37 mils? 36 mils being here at the bottom and 37 mils being here at the top. Have a bit of a discussion with your group and see what you come up with. The answer is that we always read from the bottom of the meniscus. So in this case, it's 36 mils. We always read from the bottom part. Sometimes, however, we are actually limited by the instrument on how accurately we can be. What do you think the temperature on this thermometer is? We know that it's somewhere between 20 and 30, comfortably, and in fact it's actually somewhere between 20 and 25. But if we want to be really, really precise, that's very difficult. We don't know what these increments are. So we can't be exactly sure what it is. So we would estimate. So we would say it's approximately around 23 degrees. You might say maybe 23 and a half, 24, but it's very hard to know exactly. So we're limited by the thermometer and how accurate we can be. Units and averages is our next piece. So using the right units is very important in science, and calculating an average for your results is also very important. Depending on what we're measuring, we use different units or values to measure and describe quantitative data. So for this activity, you're going to have 7 minutes. In fact, I'll shorten it down to 5, but I want you to brainstorm with your group as many different types of units as you can. So things like, I'll give you the meter is a form of unit. I want you to brainstorm as many as you can, and then once you're done, you can compare with other groups and see how many they have. They have to be written down. You can't just say in your head, we had 20, and then try and think of them. You've got to write them down. So as many units as you possibly can. Okay, so now I want you to complete the following table. I've given you what we're measuring. I've given you an example, so the common unit that we use, such as the centimetre or the kilometre, the equipment that we would use to measure it, and an example of something that you would measure of that kind of length. So I want you to complete the table. So either create this table in a Word document on your computer or write it by hand in your book, but pause the video and fill out this table here. So in terms of the solutions, temperature, the common unit is degrees Celsius. We don't use Fahrenheit, that's American. Degrees Celsius, or often there's another unit called Kelvin that we do often use at higher level science. The equipment could be a thermometer, could be an infrared thermometer, it's entirely up to you. Mass, common unit would be grams and kilograms. Scales, electronic mass balance is already given. An example might be calculating the mass of a person or measuring out butter for a recipe. Volume, millimeters, milliliters and liters. The equipment to do that could be a beaker, could be a measuring cylinder. There's quite a range of those things. Anything with some sort of a flask with increments on it. An example could be, again, if you were cooking, could be measuring out an amount of liquid, amount of water. In science, it could be measuring out a certain chemical, anything like that. Time, the common unit is actually the second. We use seconds a lot more often than we use minutes and things. It could be hours, days. There are also time units, but seconds is certainly far more common. Equipment for that is really just a stopwatch or a timer. And an example could be timing the 100-meter sprint for sports day coming up, or timing how long it takes an ice block to melt. So let's say we wanted to time how long it takes someone to eat dry wheat bix. What do you think would be the best unit for this? It seems realistic to the unit would just be the number of wheat bix, but is it going to be a really big number or a really small number? And if you've ever tried the dry wheat bix challenge, it's very, very difficult. So we're talking a very, very small number. But in contrast, what if we wanted to measure the length of a soccer field? What kind of units would we use? Would we use centimeters, meters, kilometers? So the units are obviously depend on what we're doing, and you need to think about what's the most appropriate unit for it. What if we wanted to measure the distance from Earth to Mars? That's huge. So in this case, even kilometers could become a little bit ridiculous because the number would be so massive, and we do have bigger and bigger units that we use for that. So it's really just important to understand that the units can change depending on what we're actually measuring. So just as a side note, a fun fact is that the distance from Earth to Mars, or the Sun to Mars, is 142 million miles, or for us that use proper units or metric, it's 229 million kilometers. So here you can see this other unit, and they call it the AU, 1.5 AU, and an AU is just the distance from Earth to the Sun. So it's 1.5 times the distance from Earth to the Sun to get to Mars. So it's a very, very long way. Now we're looking at averages. So you may have already seen this in maths, and this should just be a bit of revision, but this is very, very important in scientific calculation. So an average is a way of taking a whole bunch of data, which we call samples, and all of the data may be slightly different. It may not be exactly the same. So the average is a way of giving us the most common or the most likely result just from having this whole bunch of data that fluctuates slightly. So rather than just picking one and saying, I'm going to use that, we take the average, and that gives us sort of the best way of finding what the most likely result is. So in order to do that, the most common way of taking an average is adding all of the data together and dividing it by the number of values. So for example, if you measured the heights of 4 people in the class, you get the following heights: 164, 173, 156, 167. We want to know the average. So just pause the video real quick, calculate the average for me, and then I'll tell you what the answer is. So we add all the numbers together. The sum of that is 660. We divide it by 4 because there were 4 values, and the average height of the group is 165 centimeters. So that's sort of the most common or the most standard height in amongst that group. That's what the average gives us. So we're going to skip this activity. We'll do this next lesson, measuring the height of each member of your group and finding the average, and combining the data to find the height of the class. We'll do that next lesson. So now we're looking at variables. So a variable is a thing that you change or that is changed during an experiment. And there's two main types of variables. We have the dependent variable and the independent variable. A list of some of the common variables we see are things like this. So mass, angle, voltage, power, air pressure, volume, force, acceleration, time. These are a whole range of variables that you can see. There's lots and lots of them. An independent variable is a variable that does not depend on other things. So it does not depend. So independent, just like an independent person, doesn't depend on people, doesn't need other people. An independent variable doesn't depend on other things. So it's the thing that you change in an experiment. And it's also the thing that we graph on the x-axis. So these are three very important points, and I highly recommend you write them down somewhere. So start a OneNote page with notes, or if you've got a book, that's even better, write them in your book. Independent doesn't depend on things, it's the thing that you change, and it's graphed on the x-axis, which we'll see when we look at graphing skills. The dependent variable is kind of the opposite. It's the thing that changes in the experiment as a result of what you've changed. And we'll cover that in a little bit more detail. You measure the dependent variable. So I change the independent and I measure the dependent. And the dependent variable is normally graphed on the y-axis, which again we'll cover when we do graphing skills. The controlled variable is the last one. So this is just any other variable that might affect the result, and we try and control this thing, or we try and stop it from changing. So if we look at, say, how long it takes to melt water, one of the things we want to consider is if we want it to be the same temperature, if we just want it to be room temperature at, say, 23 degrees, we don't want that temperature to change. So that would be a controlled variable, and we would think of ways, how can I set the temperature in the room to 23 degrees so that it doesn't change? If it does change, then that's created another variable in my experiment, and I don't want that. And I'm only trying to test very specific things. I don't want other things to be changing as well. So when we look at dependent versus independent variables, often people get these two confused. Sometimes if we just say the phrase out loud, it kind of makes it clear which one is the right variable. An example of this is, how tall a plant grows depends on the water given, versus how much water is given to a plant depends on how tall it grows. So if you think about these two statements, which one of these kind of makes more sense? And hopefully you see that plant growth is the dependent variable, because the growth will depend on the water. The amount of water doesn't depend on its growth. Another example, a student's grades depend on how much homework they do, versus how much homework a student does depends on their grade. Which of these do you think is the dependent variable? Hopefully you said that grades are the dependent variable, because they're going to depend on how much homework. If you do more homework, which is the thing you change, the thing that you can measure is your grade. Another example, the temperature of the water depends on how much time it is heated for, versus the time the water is heated for depends on the temperature. Again, hopefully this kind of jumps out at you which one makes more sense when you say that statement, and the temperature would be the dependent variable. If we change the time, the temperature will increase. It doesn't really make sense to say that if we change the temperature, the time will increase. Time doesn't really change, we just measure it. So here's another example. We've got independent variable and dependent variable. As stated before, the independent is the thing that we change, the variable is the thing that's affected by the change, and we measure this. So it could be the amount of water, and the thing that we measure that affects that is the size of the plant, the number of the leaves, whether it's alive or whether it's dead. They're examples of a plant-based experiment that we could do with two variables. Now read the following experiment and identify which of these is the dependent and which of these is the controlled variable. Patrick wanted to test if the temperature affected how fast milk goes bad and curdles. He left milk in a room temperature cupboard, a fridge, and an oven that was turned on low heat. He then measured the mass of solid material found in the milk after 10 days. So which one of these is the independent variable, which is the dependent variable, and which is the controlled variable? Pause the video, chat with your group if you wish, and then I'll give you the answers. Okay, so if we read this, he left it in a room temperature cupboard, a fridge, and an oven. So these are things that we're changing. So ultimately we're changing the temperature of the environment. So you could say the place it was left, and sure, that would be a thing that we're changing. If you think about it, does the room depend on anything, or does the fridge depend on anything? Nothing is changing the fridge. So these would be the independent variables. The thing that we're measuring, he said he measured the mass of the solid material. So the mass of the solid material is the thing that we're measuring. So that's the dependent variable because it depends on temperature. And then a controlled variable could be something like days. We're controlling the time that we measure all this. So you could say 10 days is the controlled variable. You might also say the temperature of each of these things. So the temperature of the cupboard, making sure that the fridge stays at the same temperature, make sure the oven is on at the same temperature. They could be examples. Another one could be the type of milk. So we obviously don't want to use different milks for each experiment because we've changed something. We want the same milk for each experiment. So they're examples of independent, dependent, and controlled variables. So from this lesson, the main objective is understanding qualitative versus quantitative measurements, taking accurate measurements, and remember it's the bottom of the meniscus that we read from. What is an error and what causes an error? Units and averages, and variables, independent, dependent, and controlled. So some of the main buzzwords that we've seen today are things like accuracy, value and values, data, and units. From here on our OneNote page is the link to a quiz. Use the student link and that'll give you a challenge. It's based on this kind of stuff and it's going to rank you against the class. If you finish this, you can go on and watch the video on Excel graphing skills, which is also linked on the OneNote, and start working through that, which will continue next lesson.
Bye, have a beautiful time.